Oh yeah, it's apparently energetic. Look, people. That's getting I need to get some headphones on. Alright, let me get it. Oh. Anyway, good morning, party people. When I say that, I mean just to myself, really. I know no one's watching. Also, all my fans, follow me on Instagram, Brendan Lifts, or LinkedIn. That also interests you. Anyway. Yeah, so, um, there's also this. I think I'm showing anything bad, am I? No. So I'm running this right now. And so I think when we left off, I was working on getting this package to work, AGL binding. And so, since my last stream, I was able to get to work. Let me, back here. And so, since last stream, I was actually able to get to work, which is kind of cool. Um, cool and fun. Uh, and so I got to work, and so now we have the method working. Here's all the code, and if you want to use it on GitHub, it's under AGL package. This right here. Very good package. I have all documented if you'd like to use it. But it's basically just like uh, yeah, it's just this kind of refactored ETA ADA ETA ADA, and so the ADA so in this case, so we have AGL score here, right, which just takes in your okay, which takes in like your simple atom types. So in your ligand, it takes in like yeah, in your ligand, it takes in these common atom types, and in your protein, it takes in these, and so the AGL ADA score, extended atom type prediction. What that does, if we scroll down, you're going to see similar graphs, right? But now we're considering more possibilities from the atom types. And so instead of just considering, dot, O oxygen by itself, we're also saying O dot CO2 as an atom type as well. And so from that, you get different graphs. And since you have more possible atom types, um, usually you'll get more features. And so with more features, you have more predictive power. Obviously, training takes longer, um, but you can easily adjust that. Since most of these are using gradient boosting trees, it's really not like you just have to adapt to your hyperparameters for your gradient boosting trees to learn from, because it's just a long string of different. But I mean, so there you go. Generally speaking, pretty good, pretty easy. I want to say pretty easy. I don't know, maybe not. Also, this is not working, and I don't know why. I should be working far better than this. I don't know if it's like if I have it initialized incorrectly. I mean, that's what I imagine the problem. Um, because it should be working, but I just don't know. Maybe I have to like. Um, Also, if you guys have any tips and tricks for um, little old me, um, I'd love to know. Maybe I don't need to. Maybe I just can keep trying to activate like agile fast. It probably won't work, but really, maybe I guess I was. Holy crap! I forgot how to spell activate. Yeah, that's what I'm kind of first. So. Ugh. Maybe I go bash. One space. Shut the fuck up, bro. Okay. I don't even like. I just need that. I don't know. That sucks. Okay, so that's why my job isn't working. Oh wait. Oh, it loaded. Okay, wait. Took much too long. I mean, I don't know. I feel like that's a lot longer than it should have taken, but could be wrong. Yeah, probably should have taken less time than that. Um, but and so anyway, you get a big feature vector like this, and so these right here are features from your eigenvalues of atom pairs that look like this. So that's fun. And so the reason I think I went over this earlier, but the reason why it works is because of spectral graph theory. Um, I just crashed it. Okay, cool. Anyway, but because of spectral graph theory, which essentially just says that um, um, but essentially spectral graph theory just says that if you look at this again, like this graph can be its eigenvalues describes um, certain like it describes like a frequency of the graph, which is inherent to it, and it describes the connectivity. Like from the eigenvalues and eigenvectors, you can get understanding of the connectivity as well as um, this kind of inherent frequency. Um, and so from that you can get a lot of different features of a graph that are meaningful. Yeah. Anyway, moving on. So now, um, yeah, I like neat code. So I'm trying to learn neat code. Um, we'll start here. I guess we'll do C++, which I think I saw a solution to this previously, but like the basic idea is like, um, I think you start with like, you get like you do like a count, so you count the chars in the string, and you keep track of that, and then if um, it's the same count of chars, then so like then if first another so count stable, and so I think do Steve. I don't know the ASCII table off the top of my head. Um, instead, value char. Okay, sure. So for I think string. Um, okay, I guess you can just normally do it. So for that's method. So we do that, and we can do like so it's iterating each over each string over the vector, and then we'll do so it's either so for no character. We'll do try now. Yeah. Um, I don't know how to do the fancy for loops. Maybe just be for auto string and strings. I think that might work better. I don't know though. We'll see. For chart character string. Let's see if this works. Um, I guess we can do that. Okay. So yeah, now we'll see if I don't know actually how pointers work. Wait. Uh, um, and so we should get so we have character. So you int character, then we get the ASCII table value of the character. Um, So we have the ASCII table value of the character. What the? Let's just, oh, okay. Sorry. Uh, okay, cool. So now we're getting all the STD. Okay, cool. So it should be so. Okay, so then if so, you can do your vector counts, right? That's what's bad. So if we do a vector, this is bad code by the way. This is dog shit, but it's okay. You just want a solution. Um, and so if we do a vector of counts, anything like counts dot pushback. So then we can say like if. So then yeah. So if we do um count equals 0 here, and I'll do here uh, count plus equals int character. All right, and then we'll say let's say put it into the suite count stop pushback. Right, and then loop back to running again. No, oh, let's just do that. So okay, so now we have let's also there's a space. Um, okay, so now we have this. And so we can see that multiple of them share counts. And so that's cool, right? Yeah. And so now I think what we do is we can iterate over counts, right? So we can do like uh, uh, This is a very unoptimal solution, by the way. I'm just trying to solve it. Also, I'm not that good of like a programmer. So if you have any advice, let me know. So size, um, let's make it better. Um, that should work. I don't know. I could do something here. Oh, what if I just sorted them? So here's what I'm thinking. Right, I'm thinking. So what we have right now, this is not going to work. And for this reason. What we have accounts. Accounts, which is like whatever, something like that, right? Is her person watching? Really? They just me. Okay. So we have counts. And so if we did sort counts like into that, it's like sort that. Let me say like that, or I'm just gonna print it. Just like I'm just gonna do that. What? Hmm. Mm, yeah. I like it. Yeah. I do. Oh, yeah. So now they're in order. Mm. My main problem is like, okay, so even if I sort it, it's like I still have um sorted vector. Like it doesn't matter. Like, even if I sort it and I have the indices, right, and I've sorted vector. which for the example case would be like, right? Even if I have this, like, it doesn't really do anything for me because, like, yeah. So like, oh wait, this is all right. So it should be two. All right, two. All right, let's say four. All right, four, one, two, four, two. Okay. So even if I have this, right? Even if I have this, it doesn't change anything, right? Because so what if I have the index and our sorted array, right? It doesn't matter. I won't be able to tell my yeah. So it really doesn't sorting it won't do. I can sort the characters. No, I wouldn't do it. Hmm. Let's look at the solution.
We're given z minus lowercase.
Not sure. It's kind of solution I had going, but I stopped.
It. So now in our dictionary, we have grouped the anagrams together. So we just can take result.values. We don't want the keys anymore. We just want to return the values.
Okay, so I think what's gonna. Yeah.
The anagrams grouped together so we can return that and we're actually finished. So this is the optimal m times n solution where m is the
I don't know. I think this is gonna work. Okay, I'm tired. It did not work. Oh, serious. It's actually gonna flip them individually. Wow. Well, it's an interesting way of getting data. Let's cheat. I got. I'm getting bored. Okay, that makes more sense. Ugh, I hate losing. I need to become better at coding. I hate it. Well, I think I'm gonna stop it there. Good hour stream. Good hour stream with absolutely nobody watching. Gotta love it. Tools.